Hello everyone, I'm here with another video. Today I'm going to talk about concept of random of variable, discrete and continuous application of real life. Now let us see the contents. Introduction, what are random variables, discrete random variables, example of discrete random variables, continuous random variables, example of continuous random variables, applications of random variables engineering, conclusion. Introduction. Welcome to our presentation on random variables. Today we will explore the fascinating world of probability theory and its real-life applications. Random variables are a fundamental concept in its field, and understanding their importance is crucial for anyone interested in statistics, finance, engineering, or any other field that deals with uncertainty. At its core, a random variable is nothing more than a numerical value that depends on chance. It may represent the outcome of a coin toss, the number of customers who visit a store in a day, and the price of a stock at a certain time. But despite its seemingly simple definition, the concept of random variable has profound implications for our understanding of the world around us. By studying the distribution of these variables, we can make predictions, calculate risk, and gain insights into complex systems. So let's dive in and explore this fascinating topic together. What are random variables? Random variables are a fundamental concept in probability theory. In simple terms, a random variable is a variable whose value is determined by the outcome of a random event. For example, if you roll a die, the number that comes up is a random variable. Random variables are used extensively in probability theory to model real-life situations. They allow us to quantify the uncertainty associated with an event and make predictions about the likelihood of different outcomes. For example, in finance, random variables are used to model the returns on different investments and calculate the risk associated with each investment. Now let us see discrete random variables. Discrete random variables are a fundamental concept in probability theory. Unlike continuous random variables, which can take on any value within a range, discrete random variables can only take on specific isolated values. For example, the number of heads obtained when flipping a coin is a discrete random variable, as it can only take on the values 0 or 1. Another example is the number of defects in a batch of products, which can only be a non-negative integer. One key difference between discrete and continuous random variable is that the former have a probability mass function while the latter have the probability density function. The PMF describes the probability distribution of a discrete random variable, assigning probabilities to each possible value. In contrast, the PDF describes the probability distribution of a continuous random variable, assigning probabilities to ranges of values. Understanding these concepts is crucial for life applications such as quality control in manufacturing, risk assessment, and predictive modeling in data science. Now, let us see the examples of discrete random variables. One common example of a discrete random variable is the number of heads obtained while flipping a coin. This variable can only take on two possible values, 0 or 1, and the probability of each outcome is equal. Another example is the number of cars passing through a toll booth in an hour. This variable can take on any non-negative integer value, and the probability of each value depends on factors such as the time of day and location of the toll booth. In more complex examples, discrete random variables can be used to model phenomena such as the number of defects in a batch of products or the number of customers who arrive at a store during a certain time period. By understanding the probability distribution of these variables, businesses can make informed decisions about inventory management, staffing levels, and other important factors. Now let us see continuous random variables. Continuous random variables are variables that can take on any value within a certain range, unlike discrete random variables which can only take on specific values. Continuous random variables can take on an infinite number of values within a given interval. For example, the height of a person is continuous random variable because it can take on any value within a certain range, example between 4 to 7 feet. One key difference between continuous and discrete random variables is to continuous random variables have a probability density function instead of probability mass function. The PDF describes the probability of a continuous random variable taking on a particular value or failing within a certain range of values. For example, the PDF for the height of a person might be a bell curve, with most people falling within the middle range of heights. Now let us see the examples of continuous random variables. One example of continuous random variable is the height of adult males in a population. This variable can take any value within a range and its distribution can be described using a probability density function. In real life applications, this variable is used in fields such as anthropology and medicine to study human growth and development. Another example of a continuous random variable is the time is it takes for a machine to complete a task. This variable can also take on any value within a range, and its distribution can be described using a probability density function. In real life applications, this variable is used in fields such as manufacturing and logistics to optimize production processes. Applications of random variables. Random variables are widely used in various fields, including finance, engineering, and science. One of the most common applications is in risk management, where random variables are used to model the probability of losses and gains in investments. For example, in a stock market, the price of a stock can be modeled as a random variable, within its value changing over time based on various factors such as economic indicators, company performance, and news events. Another important application of random variables is in quality control, where they are used to analyze and improve products processes. In manufacturing, for instance, random variables can be used to model the variation in product dimensions, which can then be analyzed to identify sources of variability and make improvements to the process. Random variables are also used in scientific research, where they are used to model and analyze data from experiments and observations. Random variables in engineering. Random variables play a crucial role in engineering, particularly in a design and testing of products. By using random variables, engineers can stimulate different scenarios and predict how a product will behave under varying conditions. For example, an engineer designing a car might use random variable to model the impact of different road conditions on the vehicle's performance. Random variables are also used in reliability engineering, which is concerned with ensuring that products meet certain standards of safety and durability. By modeling the variability of materials and manufacturing processes, engineers can estimate the probability of failure and malfunction and design products accordingly. Conclusion. In conclusion, random variables are a fundamental concept in probability theory and have numerous real-life applications. We have seen how they can be used to model uncertain events and provide insights into complex systems. Discrete random variables have a finite number of possible outcomes, while continuous random variables can take on any value within a range. Probability mass functions and probability density functions are used to describe the distribution of discrete and continuous random variables, respectively. We have also explored some of the applications of random variables in finance and engineering. It is important to note that random variables are not just theoretically constructs but have practical implications for decision making in various fields. By understanding the properties of random variables and their distributions, we can make more informed decisions and manage risk efficiently. Whether you are an investor, engineer, or data scientist, a solid understanding of random variables is essential for success in your field. Thanks for watching this video. Please do like, share, and subscribe my channel. Thank you.